Hi, everybody. We're just going to do the first part of notes to break up this lesson. It's just a little bit longer. So if we break it up, it won't feel so long. I promise to be quick, and it's easy. It follows suit to everything else we've done. So no real surprises here. But we're talking about what happens when we have parallel lines in your triangle. It kind of splits up into parts that are proportional. So here we go. So we have a triangle here. Triangle, the big one, ABC, that big triangle. And it's saying if a line passes through it that is parallel to one of the other sides of our triangle, then it divides those two sides it intersects into proportional lengths. Let's just break this down real quick. So we have our big triangle, ACD. If you guys all see that with me? This big guy right here. So that's our big triangle. And then we have this line here, BE. Oops. That cut through it, but it's parallel to our third side. Right? We got those parallel arrows there. So if this happens, it cuts those two other sides, AC and AD, proportionally. There's many ways you can write it. The one I have over here is saying that AB matches AE, right? So that ratio is equal to BC over ED. And really, why is this important? It's just going to help us solve for missing lengths in our triangle, instead of having to use like whole sides of our triangle like we were before. It's kind of more of a shortcut than it is anything else. So let's try this out here. It says in triangle PQR, ST is parallel to RQ. If PT is 7.5, TQ is 3, and SR is 2.5, find PS. So let's label it just so we can see what's happening. 7.5, 3, SR is 2.5, and our job is to find PS. So again, we have a big triangle, PRQ, and then we have this parallel line here. So we know our triangle is being split proportionally. And you can do it a few different ways. You could like go left to right, or up and down. So I always like to start with my variable, so I'm going to go X. So X matches what on the right side? 7.5. Now I'm going to set that equal to, come back to the left side, 2.5 over 3. And now you have a very easy proportion that we've been solving for what feels like weeks, right? Cross multiply, 3 times X is 3X. 7.5 times 2.5. We'll figure out what that is. So 7.5 times 2.5 is 18.75. Our last step will be to divide by 3, which gives us X equals 6.25. Now, if you really wanted to check just this first time, just so you kind of see what's happening, if I plug in 6.25 for X, plug it in right here. So 6.25 over 7.5. We divide that out. 6.25 divided by 7.5. We get 0.83 repeating. Now let's check out 2.5 over 3. We get the exact same decimal. So do you guys see how this works? Right, we kept the ratio the same. That's how we were able to find X. Okay, let's try another one. Same triangle, PQR. ST is parallel to RQ. This time we know that PS is 12.5 and SR is 5. PT is 15, and we want to find X. And many ways to write this proportion. I'm a weirdo. I like to do things the same way. I always like to start with my variable. So X on the left side, that matches 5. Set that equal to, come back to the right side, the side we started with, 15 matches 12.5. Now we do the same song and dance, folks. Let's cross multiply. We'll have 12.5x. 15 times 5 is 75. We'll divide out and we'll get 6. Okay, last thing I want to talk about today before we end this little video lesson is just the converse, right? And we know we're just flipping the order of what we just did. So this time, we have proportional parts, so they're telling us that BE over BD is the same ratio as EA over CD. If that's true, if they are equal, then we know we would have parallel lines, or that we would have this parallel line to our third side. That's what it's telling us. So if these were not equal, oops, maybe we should go this way. If they were not equal, then we would not have parallel lines. So let's see what that would look like. So we have our big triangle here, DEF, where EH is 3, HF is 9, and DG is 1/3 the length of GF. Sheesh. How are we going to do that? Well, do we know what 1/3 of it is? No, so I'm going to call it X. And if I want this to be 1/3 of this guy, I would have to multiply it by 3. There we go. All right. Now let's set up our proportion and see if it works out. So I'm going to start with my single X. X matches 3 on the right side. Come back to our left side. 3X over 9. We'll cross multiply here. I'm going to get 9X. 3 times 3X gives me 9X. Is 9X equal to 9X? Sure is. So you could say yes, DE is parallel to GH because we got a proportion that is equal. Let's try one more. Again, we have the same triangle, DEF. Let's label what they give us. EH is 6, HF is 10, DG is half the length of GF. So same thing, I'm going to call DGX because I don't know what half of anything is, right? If I don't know what the anything part is. And if I want this to be half of this guy, we would double it. And now we do the same thing. Here we go. X matches 6. Go back to that left side. 2X matches 10. Let's cross multiply. X times 10 is 10X. 6 times 2X is 12X. All right, folks. Is 10X equal to 12X? Not a chance. No. So we would have not parallel. They're not parallel lines. Okay, I think that's good enough. We'll finish the rest when we see each other on Monday. I just wanted to get some of the notes taken off the docket for then. Thank you for watching, and goodbye.